because we're here for Objective-C. Alright, so this is for the people who just got MacBooks and are just now figuring out, oh, we're taking a programming course. Yes, we're taking a programming course. So I'm going to review Objective-C programming from scratch. So if you got your MacBook, turn it on, power it up. You got Xcode installed, you did that from last time. Go ahead and open up a blank Xcode project if you want to follow along. And just create a new project. And, well, let's do an iOS project. Although, we're just going to use it for the output. It's going to be, iOS is going to be the input, the output mechanism. The programming we're going to do is going to be Objective-C programming. And it's going to be just basic Objective-C. But a lot of people like the iOS background because it's, I don't know, a little bit more interactive versus a command line console. I mean, even when you teach basic C programming and Java programming, people don't like the command console. They like the GUI. You know? So the GUI is a little bit more exciting. We do some more stuff with it. So let's use the GUI. We can also use the command console inside of the GUI, which is kind of like, you know, the NSLog, which I'll show you. So go ahead and create a single view. So up here on the left-hand side is a complete review from day one. And what I'm doing is going to spend a little bit of time in the morning here and repeat last weekend. I'm going to give you the entire weekend in a couple hours here. So it's not going to be the full version of it, it's just a summary of it. In the iOS section, click on Application, click on Single View Application, click on Next. Give your application a name. We're going to call this Saturday School. Because this is really school on Saturday. Saturday School. I could put daycare on there, but nah, we're really just doing school here. For Breakfast Club. We actually here, let's put here Breakfast Club. This is the Breakfast Club. We're going to sit in this room 8 hours. So, you guys familiar with that movie? No? Okay, we'll go back to Saturday School. You got some extra reaction of that one. Saturday School, there we go. So, the organization, I'm going to leave it I to you. You know, if you're doing this yourself, you could, whatever you put in here will automatically show up every time. So put something in there that you like and just keep reusing it if you wanted to. If you have a company URL or something, you can put that in the company identifier. So, like, this is where it's just really going to turn into your path, essentially, for your project. And now on the bottom, you may have noticed I switched it over to iPhone. iPhone, you have iOS, has iPad, iPhone, and Universal. Just the same way as, you know, we can build one project for one interface, one for the other, or one for everything. So I'm going to make it iPhone because I really don't like the way that the iPad simulator looks on my computer. So I'm just going to select iPhone. Plus, I'm just going to throw this away when I'm done with it. But you can use this one for your assignment number 6 if you wanted to, actually. You can write your assignment number 6 right now. So I'm just going to save it to the desktop. So I got my project saved. And that was the easy part. Well, not too hard. So the interface is Model View Controller. This is the view. This is probably the easiest one to comprehend because the view is just our user interface. Our controller from the Model View Controller, if you're not familiar with Model View Controller, it goes back from, well, actually I'm thinking about Park Place or Digitalk, which is Smalltalk language. It's pre-Smalltalk, but Smalltalk was really the first object-oriented programming language that kind of took on that concept. It's called a design pattern. Software engineers use it all the time with Java, C++, Objective-C. It's called Model View Controller, or MVC, if you're not familiar with it. It's used as a design pattern. So we have our functionality separated out into different classes or different objects, and the objects are responsible for certain behaviors. And as long as we can dissect it all out, it makes a clear pattern. So we have the view, which is the kind of the MVC, the V part of it. This is the view. The controller is actually called a view controller. And then the data, I could call it a data model. So they call it model. It's really a data model, storage model. It's generally referred to as the control, maybe. And the iOS is the app delegate. So the model is the delegate.
This is the controller?
This is the model. Of the model view controller is the model, the data model. Is in the generic project we have model view controller all in one that we get as a template. So we start out with the model, which is actually kind of funny because this reads in MVC order. The model comes first, which is the way they organize the classes for. And then I think this was just basic coincidence actually. It's not necessarily intentional. But the model is this app delegate. And then the view controller is, well, actually, this is not in order because we have view controller, then we have view. Here's the view. Here's the storyboard is the view, and then the view controller. Model view controller.
Recorded?
Huh?
Is this class being recorded?
This lecture is being recorded, yes.
Okay.
So you can watch it over and over and over again until you're blue in the face. No. Or until you understand model view controller, one or the other. Or both. So, actually, at the rate I'm going this morning, probably both. So, you know, app delegate is actually kind of interesting. It is the model. It also could represent the data. It's really the traffic cop. So we got a traffic cop that stands out there. We got controllers that control the view, and then we got these dumb views. And I call them dumb views because that's all they are. They're just showing the user something. We have to have a controller to control the view. Then we got to have a traffic cop to control all the different view controllers to make them all work together. And that's a model view controller. And it's core object orientation, actually. So it has nothing to do with iOS. It has nothing to do with Apple. It came along with Digitalk, Park Place, Digitalk, or Park Place, Xerox Park, actually, from the beginning. This was the foundation that they did Windows off of, actually. Windows operating system is loosely interpreted as a model view controller design pattern. We had the view, the window. The controller are the icons and the interface, the controlling mechanism that shows which is going to run first, second, third, how they're going to run. The data is along the lines of the registry and the mechanisms within inside of the kernel to organize the views and the controllers. So this is a traffic cop. It's the kernel level stuff. So in a Unix system, the model is the kernel. The view is the desktop. The controller are all the applications you're running on the desktop. Kind of, you know, you can break down almost anything out into model view controller if it's object-oriented in nature. Now, some of it loosely conforms, some of it is a lot more strict. This is very strict. If you compare this to Android, Android is kind of a loose interpretation of this. So we can also add our other data to this as well, which is what we're going to do right now. I'm going to go and make some people and some employees for you just so we can review these concepts. So object orientation is all about the object or the class. We create classes, we make instances of classes, and we use the classes. So with a blank project, if we run it right now, and actually this is a good test if you haven't ever run an Xcode project before, you'll have to click through a bunch of prompts and stuff. I've already clicked through mine because I've run one before. But you're going to get a little blank little screen that comes up. Most likely you're going to have iOS 7 installed, and then if you do, the screen's going to look, where is the screen? The screen's coming up. Thought I said to run it. Yep, it's running it on my iPad. Okay, so I have my iPad connected. And for those of you who came in late, and here, actually, I can show you my iPad here. It's just a blank screen. So, let me unhook my iPad, actually, so I don't have to worry about this. There we go. Now if I run it, I'm going to see it on the emulator. You don't need a device to run these. In fact, if you don't have a device, let's just take this device out and put it on something else, like an iPhone. Oh, let's go iPhone 4.0 inch. There we go. If we run it on the emulator, good morning, then it'll come up on the screen instead of my iPad. For those of you who came in a little bit later, and you have a device and you have a MacBook, after lunch, we're going to set up developer accounts for anyone who wants one. So just let me know. Make sure to come back from lunch and be here this afternoon. And if you have your device and you have your MacBook, you need a MacBook for it, then we can get you a free developer account. Otherwise, it's $99 a year. Only thing with the developer account is that you can't stick anything into the Apple Store. What you can do is what I just showed you a few minutes ago was run it on your device. You can hook up your device, Xcode recognizes it. It's nice because then you can carry around. In fact, I have apps on here. In fact, here's Start School. It doesn't do anything, it's just blank, but it's now installed on my device. So I can carry it around and show my friends, hey look, it's a blank screen.
But we don't need to get it connected.
You don't need what?
Like every time we don't need to connect it.
No, just because you have it doesn't mean you need to use it. So I unplugged my iPad actually, so I don't have that problem again. But yeah, it's optional. If you do that, you may have noticed up here, you see it. Well, it says iOS device, but before it said Barbara Hecker's iPad on there. It's an iPad Mini is what I got. So it works with iPad, iPhone, iPod Touch works with iPod Touch. So that's a cheap way. In fact, a lot of people do that. They get the cheaper devices and then plug. iPod touches are pretty cheap, especially on Craigslist. Plug it in, you can test with it, play around with it. The only problem is, if you're really going to do this seriously, you're going to need the real devices. You're going to need one of each, essentially, because your app's going to look different when you rotate it. It's going to look different when, different types of screens and environments. And if you're going to deploy an app and you've never seen it work on the device, it's going to be pretty hard to, actually kind of predict what it's going to look like. And that might look like crap, and people might go, well, you don't even know what your app looks like. It's like, it's not really good practice, actually. If I were deploying an app, I don't want the world to think my app looks like garbage. Maybe if you're lucky, I'll show you the one I'm working on. I'm doing an app. I do children's apps, by the way. So I have, I like the easy logic and the fun part of it. So I'm working on I can't say while I'm recorded right now, but I have one that I'm finishing up, which is really cool. And so a lot of hobbyists do this. I consider myself more of a hobbyist in terms of that. I'm not trying to make my living deploying apps, but it's actually kind of fun to see your app in an app store, or to play with your app, or to have somebody else look at your app, and they don't even know who you are, but they're using your app. That's actually kind of fun. So. But yeah, I like games where you can just drag, drop. We're gonna build a couple games today. We'll do a puzzle, maybe a slider. We'll do, just take an image off the internet or wherever, cut it up in little pieces, put it on a canvas, and use your fingers and move the pieces around. Create a puzzle, something like that. It's really fun. So my puzzle is just gonna use square boxes, but you can be more creative. Use dangling, curved, jagged lines or something. Make real puzzle pieces. Actually, that's kind of cool. So that's one of our apps that we're going to be building today as well. So, we'll definitely make some games by the time we're done here. All right, so going back to Objective-C programming, which is what we're going to try and accomplish this morning here, is let's just build a simple project, and this one's not really going to do very much for us. I don't know, maybe I can get a little creative as we go through this. But go ahead and click on the main project folder. And we're going to add a class, because what I want to do is put persons, employees, and let's just build an ITU school or something. So I'm going to click on either the main project or the main folder. We're going to add a class to the project. So go ahead and go File, New, File. So File, New File brings up this little screen here. Just choose a template for your new file. And I believe I may have even gotten as far as protocols last time. I may not have, or categories. I'll review that a little as well today. And we don't necessarily need to do test cases yet. If you take a testing course, I'll save that one for that. But we're just going to create an Objective-C class. And the funny thing is if you click on the Coca down here on the bottom, you also see Objective-C class. We want to do Coca Touch Objective-C class. Because Coca is going to inherit from NSObject. We don't want to go necessarily from NSObject. We want to go from a view component. So we're going to go from a UI view controller. So if you click on the Coca Touch up here, you get pretty much the same thing. Objective-C is Objective-C is the point I'm trying to make. It just depends on what you want to use it for, what kind of interface. So if you go ahead and click iOS, Coca Touch, Objective-C class, hit on Next. Let's call this one Person. And so if you call it person, the subclass is going to be NSObject, as I mentioned before. Because we're just going to create a person object. We're going to use this as data. And then in our main, which is going to be our view controller, we're going to make instances of people. And then do some stuff with it. So we don't need a targeted for iPad or an XIB interface file with this because we're inheriting from NSObject. It's not a view controller. So we don't necessarily need to add another view to it or use it in that capacity. We're going to strictly use this for data. So I'm going to go ahead and press on Next. And then I'm going to go ahead and save it in Saturday's School, which is the folder I have all my other stuff in. And you notice that now I have the new project down here. And it shows up under Supporting Files. So Supporting Files, this is a file or an object that's going to be supported by the project that I just added to the project. So, and you notice project has got two files associated with it. Just to go back from the beginning, we have person.h and person.m, which is equivalent to person.h and person.c++ if you're writing this in C++. Or Java would be person.java. So, different naming convention. So in person.h is where we're going to stick our our interface. And so we're going to import naturally from foundation X. And last time we did the command line prompt compilation, and if that's the case, it's a framework. You're using GCC, so you go GCC space minus framework is going to be foundation as one of your command switches, because this is C++-ish compatible if you include the framework for it. But you can't do any of the GUI stuff, you can only do the command line stuff. So we have the @ symbol. It's a symbol that says this is a compiler. At's actually a compiler directive. Compiler directive says, hey compiler, this is an interface. Alright, and it's called person, and inherit me from NS object. And hey compiler, we're done. End. Which is pretty much what this is saying in human speak. And then on the implementation part of it, the import is just like the include. In fact, you can use the word include. Went through that last time actually. And the differences between the import and the include is the import links it dynamically, the include does it statically, which you don't really need to know, but C++ is a static language and Objective-C is 100% dynamic, which is, a lot of people don't know that. It's kind of a trivia question, but anyway, so nothing you really need to know for the class. But here we have a, hey compiler, I got an implementation and I'm going to implement person. Hey compiler, I'm done with my implementation. So all the code you're going to write is going to be in between the hey compiler and hey I'm done. And hey compiler, I'm done. So because that's where all the code's going to go. And the .h file is where you're going to stick your data members and your member functions. Going back to the concept of object-oriented programming. And we got two components, but two different ways of doing it as well in Objective-C. If we're going to put data members in, and this is where C++ people go, what? The data members actually go in the beginning, in between opening and closing brackets. So if I were to put something in here like and when I mean data member, I mean the data. So all objects have two components to it. They have data and then they have properties. Properties are the member functions in C++, also called functions. Languages like Java, C++. They call them properties actually. Properties, member functions, whatever you want to call them, it's fine. Those are the methods that you're going to stick below it. In C++, you stick it all between the opening and the closing class definition. Objective-C, you break it out into two components. One's the data, the other one. So it's a clear distinction. As an example, up here, if I wanted to do it, I could say integer I, and then I got I. So if you took a basic programming class years ago, you know about integer I. It's a variable. So you notice it got a data type and a name. Just the same way as I can go float F, and I can go double D. So there we go. We got some data. And then we get to this. You know, lo and behold, the string. We're going, oh my god, this string. What am I going to do about this string? And then you realize, oh, well, we got this thing. You can call it a string, but it's really an object. So these are not objects. These are primitive data types. And then we also have objects in the language. As an example, we have an NS integer. So I could go like this. And all the objects in Objective-C that are built in, that are used for data types, all start out NS. Next step is what that stands for, which is where Objective-C came from, actually. So NS integer, let's just do a string here. My name, or just put here name. This is a person. NS, oh no, let's go NS integer. And an asterisk age. And you might be wondering, well, why do I have to put an asterisk in there? Because all objects are pointers. So if you don't like pointers, you're in the wrong class. So, but you know what? Java uses pointers. Programmer just never types a pointer. C++, people don't like pointers. They don't use pointers. Objective-C, you have to use a pointer. There's no choice. So you put a pointer in here, and I got a couple pointers in here. One for a name, and the other one for an age. Hey, glad you could make it. You missed the attendance. I'm kidding. I did get a moment of silence. My God, I missed the attendance. Why am I even here? It's not like that. Anyway, so we have primitives in here. I'll even do this because what I'll do is I'll post this video. I'll post this file with the video. So I'm going to go here because you can use this because what I'm also doing this weekend is sort of giving you information that's going to be on the final because usually people start wondering what's going to be on the final. Stuff like this, questions like this. It's going to be a multiple choice final, but questions like, you know, what's the difference between a primitive and a, you know, an object, data type? You got to use pointers for, you have to use a pointer for an object. You don't have to use pointers for primitives. You also have to allocate and initialize objects. You don't have to use that for primitives. So, long story short, we have, these are primitives, and down here we have object data types, objects that use pointers in their implementation. So we put the data in between the opening and the closing brackets, and then underneath it we're going to put the member functions. And because we are defining a .h file, this is the interface, we're going to put function prototypes or method prototypes, or however you want to call them, property prototypes in here. So the common ones we're going to use is going to start out with a minus sign, because remember we have the minus and the plus. And if you just came in late, we were reviewing what we did last weekend. And we're into it already, so I'm not going to start from the beginning. But we start out with a plus or a minus. We could actually start the method out with a plus if we wanted to. It's a symbol we have to put in. If we don't put the symbol in, we're going to be in trouble, because we don't know whether it's a class or whether it's a method for an instance. So the minus means it's an instance method. The plus means it's a class method. What does that mean? Instance methods are run on instances of objects that are created of that class. Class methods are run without any instances. They're just run on the class itself. So class is more like a function. Instance is more like a method. If you think about the concept in terms of object orientation. But because we're inside of a class and we're defining it, it's going to be called person. We're going to create a method. So in in Objective-C, the data type comes first, just like it does in C++, but it comes in and out of, I'm going to just put void in here, opening and closing brackets. So I'm going to put in here a void, this one's going to get something. I'm going to write some setters and getters. So I'm just going to do it for I, actually. Could do it for name. Let's just do it for name. We'll do it for name here. So if we're going to get a name, we're not going to return anything. I'm just going to have, just going to assign the name. So if I do that, I go here. I'm going to call the method something. I'm going to call this one get name. And the get name, I'm going to put a colon here to signify that I'm going to actually ask for something. And then I'm going to list my parameters. And the thing I'm going to ask for is, let's call it a uname or something of that nature. Which means, give me a uname. And then my syntax is not right. So I'm going to come back up here. And because I was doing C++ earlier today, I'm going to actually do this. Yeah, I know. I have to put the data type there. Yeah. And a string. And a string. Actually, I guess I don't really have to. Yeah. Uname. There we go. Actually,
semicolon.
Yeah. No.
You just have to define the method, right? So semicolon.
Yeah, I'm sorry. You know what? I'm just waking up. Here we go. Uname. Let's just see. Maybe I'll just use this. Your expected identifier.
Close bracket.
No. What do you mean close bracket?
Yeah, after the asterisk, there should be a close bracket. After asterisk, that should be.
Oh, yes. Okay. I'm awake. Okay, thank you. I went from, I was teaching yesterday a C++ course, and I'm like, oh my god, now I gotta remember the syntax. I was gonna pull out a cheat sheet, but I'm like, no, it's alright, I could do it. And I totally forgot, I'm not writing implementation. I'm in the .h file. So this is the, alright, so just for those people who are slightly confusing here, if I were writing this in C++, which is what I wanted to do, because I'm thinking in C++ right now, this would really be void. I'll just write it in C++, and we'll see. And I have to stop thinking about C++, actually. This is not going to help me stop thinking about C++. Oh, did I just misspell name? Uname. There we go. Name. There we go. All right. So if I were writing this in C++, uname, hello, it would look like that. But this is Objective-C. What we want to do is change it around a little bit. What we have to do is put a colon, because there's no commas in Objective-C, there's just colons. And then we have the data type along with, and the data type always is in front of the opening and closing brackets. And because we're a pointer, we have to actually, because we're an object, we have to use a pointer. So we have an asterisk here, and then we have uname as the name of the parameter that we're going to take in. So when we run the method, we would run it like this. If we had a method of an object person and we called it P1, we would go basically P1, P1 space get name, and we put a colon here, and then we would stick the string in here. And we would run the method like that. This is going to be bad syntax because I don't have a P1. I don't have a variable called P1 yet. Because I haven't made an instance yet. But long story short,
Okay, can you write it in the H file?
you can't write it in H file. I'm demonstrating it. This is supposed to be wrong. Right now I'm intentionally doing it wrong. I'm doing it wrong two ways. One, I'm writing C++ code here. So this is the, let's just do it this way here, because I wanted to basically turn this into a teaching example. So I'll put comments next to it. Hello. And we have, this is the C++ equivalence equals this one here. This is how you would write a method in C++. And then here, we will put in here how to run the method on an instance named P1. And then if we were doing this in C++, how to run same method in C++, it would look like this. You would run the method with P1 dot get name, and then you'd stick the name in here. Bob, Barb, whatever this was. Alright, so that was my attempt to give you a comparison and contrast between two languages you might be familiar with, maybe not. If you're not familiar with C++, don't worry about it. You don't have to learn that for this class. You're only learning Objective-C. So, but what we have now is a method prototype. We could do the same thing with the other ones, or we could possibly create a property. I'll create a property for you later in a few minutes here to show you the contrast. But if we wanted to get something, then we're not going to use the return type of void. So we're just going to set and get the name here. So if we were going to get something, we were going to get an NS string actually. And if we're going to get an NS string, it's going to be a pointer. And this one's going to be a wait a minute, this is going to be set name. So let's put here set name. There we go. And this one's going to be a get name. Ah, man, I cannot type today. There we go. Do you hear someone screaming? So let's see, what did I forget on that? Nothing on that one here. So we got, yeah, I do hear something. No way. All right, so set name and get name. Are we good so far? All right, I might need to have you help me in the front row again here, but let's see. So if we go back to person.m, we are back here. Now, in here we would write the implementation. So because I'm such a terrible typist, I'm going to go like this actually and kind of just do a little cheat sheet. These are method prototypes, which means it has the same signature as our method implementation. So I can just use them as is and just add the opening and closing curly brackets and insert my code. So the code I'm going to put in here, I'm going to stick over here. I'm going to take out the semicolon and put in the opening and closing curly brackets. And then now what I'm going to do in this file is give myself the method implementation. What did I do here with the get name? No. Open, closing.
The person should be, after the person, there should be an open curly bracket and...
No, not for the implementation. No. Oh, let's take a look here. Control reaches end of function.
We need to write return.
Oh, you're right. Thank you. So get name is not a void function. It has a return requirement. See, that's the problem with Objective-C. That's the problem with Xcode, actually. This is one of my biggest complaints about Xcode. I'm not done writing. I haven't filled in the body of this method yet. I haven't even gotten there yet. But it's already going to tell me this is an error. And it leads me to believe that there's an error with the method declaration, and there isn't. The problem is this is lack of this return expression. That's why I actually went over here and I looked at this and went, control reaches the end of a non, well, now its expression's bad, but let's see. Here we go. Let's go back to this error. That the control reaches the end of a non-void function. I went, oh, I didn't finish the function. Well, I'm not done with it yet. Why is it going to error check it for me? But anyway, you can turn that on and off, actually. I like to leave it on because it sort of helps me sometimes when I'm writing the code, because then I can, what did I forget? So it's basically the get name is going to return the name, and the name that we're going to return is called name. So I'm just going to put in here return name. If I put in return name, I've returned this name up here, and this name right here is the name we're going to set with the get name. So if I go back to the .m file here, what I'm going to do is take a uname and have it equal to name. And then now I have the name that was passed to me by the set name given to me, and now it's going to be sent and assigned to name. And now I'm going to return the name. So those are setters and getters the manual way. I'm going to show you how to do them the automatic way using properties and Synthesize in a few minutes. But just so you have a kind of a clue in terms of data, you want to know this for the final, obviously. This is basic core. You're going to need this for project, for assignment number 1 and number 2, and we're actually going to need it for all of the assignments. So this is a basic class that you're creating. In your assignments, you'll be doing a ship and a cruise ship and everything else. In fact, let's make an employee. So if we make an employee, we can go back up here, either click on the major project or click on school, Saturday school, it doesn't really matter which one you click on. Go file, new again. It's the same process we did before to make a person. Go ahead and on the iOS side, go ahead and click on Objective-C class. Actually, it doesn't really matter which one you're on at this point because we're just creating a regular old class. It's just not assigned to an interface. And this time we're going to call this one employee. And employee we're going to inherit from person. If you go in here, sometimes you'll see person in here. LMN, let's see. Nope, or you can just type in here person. And you see person shows up. If you leave that out and just leave it on NSObject, you can actually change it. Where you're going to change it, go ahead and save it, is in here. So in employee, if you didn't select person or put person in there, it's going to say NSObject. Just the same way as our person says NSObject up here. So now what we did is we inherited a class from person. We called the class employee. And so now we can add more data to employee, like, each employee is a person. Going back to that concept, and well, some of them aren't, but we could put in here an integer ID. There we go. Where we have an ID. Am I in the H? I am in the H. Integer employee. I just call here employee ID. There we go. ID is a reserved word, by the way. I can tell it was a reserved word because when I typed in integer space ID, I got it all in purple. So keywords are in purple. Comments are in green. So you can see by the color coding I can help you on. Again, that, I just kind of like look at that and went poof instantly. So the more you work with the interface, the more you'll get familiar with the color coding system. Obviously any errors are in red. You don't want to see red on anything. Anything yellow is a warning. But I would take those warnings more seriously. Some of those warnings are lightweight errors, but the program's still not going to run, even though it's a warning. So just because it has warnings doesn't necessarily mean it shouldn't have been errors. Anyway, so I added now to an employee. I've got the employee ID. I can do the same thing. We can actually we can just set the ID. We can just leave it alone. Actually, here I'll just do some. I'll do some here. We'll do some creative cutting and pasting. I'm going to do some setters and getters on the IDs as well, so I have something to demonstrate out into the driver program that we're going to do. So what I'm going to do is just paste this in here and then change it around so I don't have to type. So we don't have a get name, but we have a set, and this is going to be, I'm going to put this on an E here. Employee ID. There we go. So set employee ID, and this is not going to be this is going to be a integer. So it's an int, and because it's an int, we don't need the ID. We don't need an asterisk there because it's not a pointer; it's a regular old integer. And what's this one? We're going to return it. This is also going to be an int. We're going to return the get ID. So get employee ID. And, there we go. So now we got, so I'm going to do the same thing. I'm just going to cut and paste here and stick this over here, build up some functionality. This is what you're doing, by the way, in your assignments. You're doing exactly this, but you're doing something very similar on different themes, actually. So let's see, get rid of this here. And I'm going to return the employee ID. Let's forget about the errors for a second here. This is going to be employee ID is going to be equal to the ID. All right, so we have the employee ID is equal to the ID, if I spelled this correctly, with a lowercase d. And then we have a return employee ID. So it's the same thing as before. These are called setters and getters. They're used to, and these are by default, these are public, and the data is private. The data is private because we've enclosed it inside of opening and closing brackets. It's only visible inside of the class. It's not visible outside of the class. What's visible outside of the class are the member functions that we're going to run, the public ones. Okay, so in order to use these guys, we have to make instances of them. So I'm going to use the view controller, actually. The view controller, we're going to start out making a view controller that works just with a console base, and then we'll have it work with the GUI. So the view controller is a viewcontroller.h and a viewcontroller.m. View controller is the .h. You can see where the inheritance is coming from. It's coming from a UI view controller. Well, it's a view controller. It's like kind of like an NS object, but its job in life, it's extended further down the hierarchy. Its job is to control the UI view. The UI view is part of the storyboard, main.storyboard. So its job is to control that storyboard. So I'm going to leave the .h alone because I'm not going to really do anything to it. I could import, and it's not a bad idea to import in here. Import the person and person.h, and then import employee.h. That works too. What did I do here? Let's just take a look. Not found. Well, let's see. Oh, that's why, because I didn't do this here. So inside a person, inside of employee, I should import person. I did import person. That's good. Well, we'll just leave it out. It's okay. So we're just go back up to here. The error message went away on me, which is good. Should have been okay. It was okay. Xcode's a little bit slower. I had some recording software running. It takes a few minutes. So if there's an error, just relax, click around a little bit. The other thing I like to do, didn't do it, I probably would have done it next, would just save the project. When you save it, it refreshes everything. Otherwise, you have to wait for the Xcode to catch up with you. But anyway, so I've got my two imports and I've got my UI kit import. I can also go over here and start using stuff. So in the life cycle of a program, this is the view controller for a model view controller is sort of like main. It's main from a procedural or imperative programming perspective, or from a object-oriented perspective in C++ or Java. Main's the driver program where all of the functionality starts for the application that's running. So we're looking at the view controller. View controller is specified by the app delegate. If I look at the app delegate up here, I can see in my life cycle of the app, I have the application itself in terms of its definition, which is going to be, the launch properties, and did it finish launching, with the options of how we're going to launch it. And then we have the, it would be active. Did it go into the background, did it go into the foreground? What happens with the app throughout the entire life cycle of the app is controlled by the app delegate. And that's the basic implementation of it is from a UI responder, and it follows the protocol of a UI application delegate. And the application delegate protocol gives it all the rules it needs. Remember protocols, there's a little review of that concept as well that we covered last weekend, last time we were here about a month ago. And protocol is sort of like an interface in Java, actually. And a protocol doesn't necessarily have an equivalence in C++, but it does in terms of another sort of interface concept, but it's not used as much. It could be more of an abstract class / interface in that language as it's interpreted. But long story short, in Objective-C, this says that we have to have all these methods over here. That's why all these methods are in here along with all these comments, but nothing's in the methods. So this is going to be our default sort of method layout. We have that because of this here. If we take this out, we don't need that. So this app delegate is an application format that's running from not NS object, but it's running from UI responder. UI responder is the control interface that picks up the clicks and the touches and the swipes and everything. UI responder is the basic responder. So long story short, that's how it gives us our interactive environment. And it's gonna, the property on here is the window. So the UI window is the window that loads. The UI window in our case, by default, is gonna load up the main view controller. Now in app development, what you can do is change it so it loads up different view controllers. And then you're gonna have different view controllers load up other view controllers depending upon what you're doing, what you're working with. So you're constantly switching back and forth between these view controllers. So in our view controller, it's really simple actually. We have a view did load. We could put some other stuff in there like view did unload, view did suspend, view went into the background, view finished loading, view started, all this other stuff we could put in there, but we don't really have to. This is sort of like our main entry point right here, the view did load method. So do any additional setup after loading the view, typically from a nib. The nib is the interface. It's the XIB file. Well, so they don't call it nibs and they don't call it XIB anymore, really. It's called a storyboard. So storyboard loads your nib. So if we're going to do something, we're going to do it in the view did load, because that's going to start up automatically. And for example, if I do something and I don't want to put something on the UI yet, I just want to put something in the console, I can do the nslog. So if I type in nslog as an example, I can put a string in here. And now I've turned this GUI application into a console-based application, which is what we're going to do first, and then we'll use it back as a GUI. And I did this a few minutes ago with a string when I assigned a string. I don't know if I did it with a string or not, but we'll just do it right now. If I put a string in here, I'm going to get an error message. If I put in here, made it to view did load, normally people go, oh, that looks like a pretty good string. What's wrong with that? You have to tell, either you have to cast it this to a string, or you have to tell the compiler use it as a string. If you want to use it as a string, that's where that at directive comes into place. I would say of everything in Objective-C, that's the only thing that's kind of odd. You'd think that they would have made it so it was more automatic. But this goes back from the original version of Objective-C. This is, you have to, the at communicates with the compiler. You have to tell the compiler, hey, this is a string. All right, whatever. Okay, if you want to do it that way, go ahead. But anyway, long story short, if I run this program right now, I'm going to have a little console window that comes up as soon as the app loads up. And it's going to tell me that I made it to the view did load method. And there it is. So I got my empty screen because I didn't put anything on it. Down in the bottom it says made it to the view did load method. So if you want to do your assignments like this, you can do it like this. Otherwise you can select the non-iOS application. Go back to the Objective-C one on the options where it says create new project, and all you get is the nslog. Those are your choices, so that's why I picked this one, because this one at least we have some GUI components to it. On the other round, what we could do is, we don't have the GUI part, we just have this without the storyboard, we just write through the nslog, so, which is the console. This is the screen. Alright, so you can also use, and I showed you this last time, you can use printf with this, scanf, you can use all sorts of different things for it. So, alright, so let's continue forward, and now outside of made it to the view did load method, we sort of want to do something So I'm going to use this as my main program because I'm not really using my view yet. Instead, what I'm going to do is make some instances of my objects, allocate and initialize my objects so that I can use them in the program. So in order to do that, I've got to actually include them. I've imported them in the viewcontroller.h file. Let's see if I have to do it again. We'll just kind of play it by ear and see what happens. So I'm going to start out, and you'll notice that the implementation looks very similar as it does in other languages. It's a matter of, I'm going to make a person, so I'm going to start out with the name of the object, person. And it's a good sign that I got recognized. And you have to give it, I'm going to call this one P1. You have to give it a name. And then you have to say, well, it's going to be equal to, and then you have to allocate and initialize it. So in order to run a method, we have to use the opening and closing brackets. So if we were going to allocate one, we'd say person, alloc, and then a lot of people do is just let's put this inside of a, this is a capital P by the way, put this inside of an opening and closing call to initialize it. So we go init. Oops. Init instead of int. I know you have to correct me on my spelling, by the way. Init is what I meant to write. Alright, and then we could use P1 as an object. So this is really two separate steps. This is person alloc, and then we can go from person alloc, we can go P1 init. Let me attempt to write this the other way. I'll make another object here. So this is the common way of combining steps, because this is going to return, this is equivalent to new person, by the way, in C++ and Java. And then from this object, we're going to initialize the object. The initializer is the constructor. So Objective-C doesn't have constructors, deconstructors, copy constructors, all that other stuff. Instead, we have initializers. The initializer acts as the constructor. You remember this part. And this is going to allocate it. We don't have allocation. We have new. We have the keyword new that does an allocation in Java and C++. We don't actually have to type in alloc, which is interesting. But it means the same thing as new. And there's no deletes. There's automatic garbage collection that goes on, so we don't have to worry about that actually. So if we did it in two separate steps, we could say person, let's see if I can remember how to do this. This is called on PP, is equal to, and then person alloc, which is okay, we've allocated one, but we haven't initialized it yet, so then another line would go PP init. Most people would combine them together because that's two lines of code instead of one line of code. And we know that this is two calls. It's one to alloc, and then the result of that gets put into here, and then the method called next runs init, which is equivalent to person.alloc and person.init. If you were using dot notation, you can't use dot notation for that. It's as a method call in Objective-C. All right, so I'll take that out because we don't necessarily need it. Instead, let's make an employee as well, because we want to just basically exercise our classes. So this is going to be E1, and this is going to be equal to, and I'm just going to do it this way here. And you're going to go, wait a minute, she's making a person. Can we do that? Not really, but we can because it's all in the same hierarchy. Actually, don't really want to. I want to make it an employee, but an employee is a person. So one of the assignments, I believe it's number 4. Uses, oh no, it's not number 5. Actually, it's the last, it's number 5. Cruise ships and ships. We can just make ships and make some of them cruise ships and some of them other ships, other different types of ships, which is really looking at this feature here, which is the is-a relationship. So any object in the hierarchy has a relationship with all the other objects in the same hierarchy. It's a single line hierarchy. One object goes to another object, goes to another object. They're all interchangeable. They're all the same. But I really just want to use another person, so I'm actually going to make another person. So I've got 2 now. I've got a person P1 and I got an employee P1. But they're both the same. They're both, an employee is a person, but a person is not an employee. So if I were to run a get ID on a person, I don't have an ID on the person. But I have an ID that I set on the employee. So, because keep that in mind, otherwise you'll come back with some interesting behavior on that. So if it does compile, it probably won't. It'll probably give you an error message. So let's go ahead and kind of see, well, let's run a couple of the methods. We'll just set a name. In fact, I'll just use person. We'll just set a name and we'll get the name. So if I say that, I'm going to go P1, and then I'm going to remember that I'm typing in Objective-C, not C++, and I'm going to run the method, and the method is going to be set name. So if I start typing in the value, I kind of sort of see it filled in for me. And the name here, this is the part I think is actually kind of confusing. It gives you the data type, but it puts those opening and closing brackets in there, thinking like, oh, I'm supposed to put it inside opening and closing brackets. Not really. You just put the string in there. So if I'm going to call this P1, this is going to be Bob. I'm going to put a string in here. I'm going to call this guy Bob. So now I set the name. Whoops, and I'm typing in C++ again. So now I have set the name to Bob. So now I can get the name. If I can get the name, then I'm going to, just say, well, that's a string. I could do a couple different things here. I can actually just create a string. And if I want to create a string, I'll just go back up to View Controller as an example up here. And let's just put an NS string in here. Now, you don't have to do it this way. I'm just going to show you how to move things around. So you can also add data to your NS View Controller. It's a class object just like anything else. I'm going to put in here NS string. And I'm going to call this one the name. Do I really have to? Nah, it's just going to be for fun here. So then I can go, well, okay, so the name is going to be equal to, and then I'm going to do this because we're going to return a string. So instead, I'm just going to get. So paste over here, get rid of this here, and say get name. And then I can do this. I can just say, well, okay, so let's just nslog it out then. So nslog, and then I'm going to put in here P1, P1's name, name is, this is why I don't type, is, and then I go, well, what am I going to put in here? I can do an @ symbol for an object, and then I can go comma, and then I can say the name. So let me show you what I just did here for a second ago. NSLog is just like printf. In fact, I can put printf underneath it if I wanted to, but I'm not going to go back to C, where I've got a placeholder here. So the placeholder here is going to essentially be filled in after I go comma. See, this is the string, and at this position, when this is a what do you call it, %sign. So I'm going to put a D, an I, an F. This is formatted output. So whatever it is here, I put @ because it's really an object. That's an object. So I could put ID, S. No, not S. That's printf. Well, actually, probably S does work. F or D is going to be for a number. So let's set P1's. We're just going to set P1's age. Actually, age. I think I have age in here. Let me just make sure I do. I do. And do I have a get name? Oh, I don't have it. Well, here, let's just do this real quick here. Give me 2 seconds. Let me just fill in the rest of this here. I will make this code available for you as well. So set age. Now that I'm really typing a lot here. Actually, we can just make this an int. No, it's an age. NS. Alright, let's just make it an NS integer. Age. This is going to be age. It's going to return an NS integer. Okay. So hold on 1 second. I'm going to show you a better way of doing this. This is the only time today I'm going to write setters and getters. After that, we're going to use property and synthesize. But a lot of times I have found out that if I use property and synthesize too soon, people go, what about those setters and getters? They lose the concept of it. So we struggle a little bit with some setters and getters. It's just tedious. You know, if you do this in Java and Eclipse, there's like menu options now. You just create setters and getters, create constructors, create everything for you automatically, which is kind of interesting. This is going to be return age. I think I called it age. Yes, I did. And then this one's going to be age. It's going to be equal to, I don't know if I'm going to call it new name. Let's just call you age. The age. That's a better one. Oh yeah, I'm like, wait a minute. Wrong one. Okay. Logically sensitive? Oh, okay. That looks pretty good to me. Alright. So now we have setters and getters for the ages. Okay, so let's go back.
Is
Yeah?
uname like for that set name?
Mm-hmm.
It should name. Is the same name equal to uname or uname equal to name? Name is the data member.
Name is the data member that we have defined for the object.
I'm saying,
Class.
is it the same like for the operator?
Uname is the string that comes in. The string that comes in is the parameter. The parameter is being called uname.
You are, yes, I mean reinitializing the parameter.
Oh, did I make a typo?
Name equal to uname. It should be name equal to uname.
Name equal to uname. Name is the data
Oh,
member.
age.
No.
Oh, you're right. You're right. You're right. You're right. You're right. Thank you. I didn't even catch that the first time. That was in there before, wasn't it? Name's equal to uname. Age is equal to age. Okay, good. Thank you. This is programmed by team here. This is good. All right. Well, that's actually good because it's going slow enough to where brand new people can hopefully catch on and see what's going on. Hopefully. Any other typos before I continue? I got set and gets looking pretty good, I think. All right, so I'm going to go back now to the view controller, and the view controller up here. Now I can run the method I wanted to run, which was to set the age for Bob or something like that. So P1. So now I'm going to run the method P1 set age. There we go. And the age, I'm going to make him 21. And you notice I didn't actually have to set it anything. I didn't have to set it a number or anything, but this is going to tell me that it says an incompatible integer to pointer conversion, sending int to parameter of ns object, aka int, which I sort of did on purpose to show you something by example here. That's going to cause an error. Actually, it's not. It's a safe conversion, but it's a warning. In some situations, it could cause an error. Actually, let's see if it does cause an error. In some situations, it does. I got 2 errors now out of that. No, maybe the errors are coming from something else. Let's just see where the errors are coming from. Nope, the errors are coming from this. So they're coming from this because it should have been an error, but it's not an error. But when I go to run it, it can't do a safe conversion because I'm mixing and matching between an integer and an object. So I either have to cast it to an integer from an integer. So I cast it to an object, or I just use it as an integer. I don't actually personally like casting it to objects. In fact, what I would rather do is cast it to, why is that? Didn't I run it with this guy already? I don't know. Unused variable. Okay. Otherwise, I would just use the age as an integer. So I don't have to take it up that. So let me show you just one real quick here. Your first choice is, it is an integer. What did I do? I used it as an object. I created it as an integer, and I used it as an ns integer. That's what I did. So I came over here. No, I used it as an integer. Did I use it as an integer? Yes, I did. Oh, I have age in here. What is this here? Oh, that's the ID. I'm sorry. I did not use it as an integer. I used it as an ns integer. What I'm trying to do is show you the differences between integers and ns integers. They're different. Int is a primitive, ns integer is an object. You can't print an object out. You can't assign an object without making it into an object. So the choice here is to do this. If I want to use it as an integer, define it as an integer, not an integer object. So here I go here, age, because really, am I necessarily going to need it to be an object? I might actually need it to be an object. And if that's the case, the return type on getAge is now int, which means I need to change it over here as well. This one's now an int, and this one's now an int. And set age, conflicting parameter types in implementation of set age NS integer. Well, no, I changed it over here. Let's see, we didn't save it yet. Set age, oh, here we go. No, there we go. But notice that those are yellow and they're not red, but they're red because they are errors. The program is not going to compile, and you're going to look at this and you're going to go, there's no red. There's no error. It's just yellow warnings telling me about this unsafe, well, they didn't say the word unsafe, but it is an unsafe conversion, which is why it gets caught as an error. It's an exception, and it's an unhandled exception. So you got you actually have 3 different ways of doing it. Either switch everything over to, if you're going to use it in main or the view controller as an int, make it an int, or cast the int to an integer object in the view controller instead. That's the other way of doing it. Or put exception handling in there and let it ride. The message that you get at runtime is because there's a lack of exception handling. It's considered in other languages an unsafe conversion. In Objective-C, it's an unknown conversion. How do we convert it? Instead of it making an assumption, it's not going to make the assumption. You got to tell it to do it. So either you got to explicitly convert it, override the exception, or change it into an integer. That's a message. That's not even an error. Yeah.
Is it the same as a string and a string with string format?
Yep.
Okay.
And a string with string format, and a string with integer with and a string. So it's the with format. That's what you're going to use with that. I actually have that in a couple of the examples. We actually went over that, I think, last time as well. So, but just reviewing the concept. All right, so I think I'm going to be good this time. Let's go back over here and see what's going on. Implicit declaration of NSLog is incompatible. Yes, it is. Because this guy, what's wrong with you? Because how did I do that? There we go. I somehow put a typo in here, changed the O to an O. I don't know when I did that. Maybe when I typed it originally. This guy's still a problem because he's not being used, but he's not really a problem. So now we have a build successful. And now we have my P1's name is Bob being printed to the screen. So notice a few minutes ago we had more warnings, and those warnings caused it to crash. Now we still have a warning, but we're not crashing. That's what I'm trying to tell you. It's the worst thing to do to troubleshoot this is to figure out, well, what one of these warnings is important, which one of these warnings is not important. When one of the warnings probably should have been an error, not really a warning. Because it was an error, we mismatched the data type. But because it's dynamic, who knows? We could just suppress that error message and just let it happen if we wanted to. We just didn't do it. So anyway, so now we have set the age. So now I could actually print out the age, and what I wanted to show you was this here. So let's go here, copy, put it underneath so I can eliminate some of the problems here. P1's age is, and then now I'm going to put in here a D for digit or decimal, or I could put an F in there. Well, we'll just put in here P1. Let's put a method call in here, P1, because it returns an integer. I get age. So instead of copying it to the name, which was a string I made a few steps ago in the view controller, I'm just going to run the method, stick it in here so I can get the age. Now if I run it, it should go ahead and give me my age down here at the bottom. Then the age is 21. We can do the same thing with E1 just like in other programming languages. I can make an instance. I did make an instance of E1. I can go, let's just do this here. Put it underneath. I'm going to use E1 as a person instead. E1.setName, and this one's going to be Peter. Let's make this guy Peter. And then this is going to be E1. And then we're going to have let's put this above Bob. We'll put this together just because when I say this, people will know what I'm doing here. And then this is going to be E1's. And that looks pretty good, I think. We'll see what happens in a few minutes here. E1, P1, E1, 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 E1. Okay, very good. Let's see what happens here. Let's change the age so we know what the age is here. I didn't set the age, did I? I left out this line here. So we'll set E1's age to 50. We'll make Peter older. All right. So let's see. See how far we got with this. So E1's age is 50, and E1's name is Peter. Okay, good. And then we got Bob, and we got P1's name is 21. So that's kind of a review of using basic syntax of running a method, creating an object, making an instance of the object, running methods on the objects, passing parameters with the methods of the objects, printing the objects to the screen, basic I/O. That's enough to get you through the first couple of assignments, believe it or not. So you have to add a few control structures to that and add some object checking, see what type it is. There's a couple little tricks about, not tricks, but there's a couple little things to do with that in terms of that assignment. But for the most part, that's the basic syntax review. So now what I want to do is show you another review using the same project. We're just going to add on to it. That's the console, but no one likes the console. I like the GUI stuff. So we'll take a look at the property and the synthesize as it's used with the GUI controls. You don't have to use GUI for property and synthesize. You can put property and synthesize in your project as is without that. Let's see. So we got a storyboard here. Storyboard is the UI. It's the view. We know that from model view control. I explained a little bit earlier. So now that we're going to use the view, I'm going to go ahead and click on this right-hand side over here for the properties on the view. I'm going to change my view. I'm going to make my view green because I like green. Oh, that's the tint. Wait a minute. We don't want to do the tint. We want to do the background color. Now I got my green background here. And so we know from last time, just to review the concept, we drag and drop when we put components onto the view. So I'm going to put a label out here. Label's going to be... this is called the Saturday School Review. And we're in Saturday School. So I'm going to go this way. That's why they should call it weekend classes. They should just call it Saturday School. Saturday and Sunday School. You know, guys, registration's starting up again. I can't believe that. This term's almost over with. Alright, so that's going to be our fancy little label there. And we know if we want to put like an image or something out there, we just put an image out there, we change the property on it. So, as an example, just to review the concept, I can here, image. A little image view, stick a little image view here. Then, a little image here. Let's go out to the internet real quick here, find a little image to use. So, there's a Saturday School images, let's see. Do they have one for Saturday School? Let's see what they got here. Oh, look, Saturday School. Free breakfast, free transportation, and free tutoring. All right. We don't have all that stuff here. That's a JPEG. I don't want to use a JPEG. I want to use a... This one looks pretty good. What is this guy here? That's another... let's see. Hold on a second. Let me just do it this way. PNG. PNGs work better, by the way. Ooh, this one looks pretty good. D school. This one here we go. What's this? Well, I guess we'll use this one. This is a test. Save image as. There we go. Let's go. What is this thing? Color bright. Color bright looks pretty good to me. So I got my fancy little image. I'm going to take my image, I'm going to drag it into my project. This is a review of some of the things we did last time as well. So I'm just going to drag it in here, put it up here inside my Saturday School. I'm going to copy it in. Another people don't know is they don't copy it into the project, and then you go delete it off your desktop. And then it's gone. It's not my project anymore. So make sure to copy it in if you're going to save it all together. And you see it right here, it's color bright. There we go. Oh, that's pretty bright. Alright, so in my storyboard, here on my image, and then I can go ahead and select the property up. So it says image, color bright looks pretty good. There's my color bright. So we're making a really nice little app here. There we go. And then I can go ahead and throw it away off the desktop. So. All right, so now I really want to do is have this person in here, so we can make some people and put their names out on the street. So what's going to call these students, or no, employees. So we already got them created, so we can just put them now. Use this as our I/O, or as our input or output, essentially. So I'm going to put another label out here. It's going to be enter name. And then on the enter name, we'll have somebody put in a name, and we'll use that name to create a new person. And then we'll print the person's name out on the screen. So we got a full circle here on using the object. This is what you're doing essentially when you're creating iOS applications. You're creating objects as the data model. You're using those objects in your user interface. Whether or not you're using them as text or using them as functionality. Usually it's functionality. Images. You can do a lot of stuff with it, actually. So here we're going to have a text field. The text field is going to be taking on the name that we're going to enter in. So here's your, by the way, this is all you really have to do for that assignment number 6 as well. So you could do this. This could be your assignment number 6 if you wanted it to be. So from those people who were here earlier when we were talking about assignment number 6. Let's see, I don't like the way that looks. There we go. Too picky on my user interface. And then I'm going to put here name. Oops, label. Let's just put a label out there first. So it's going to be here. Name is. And then let's go ahead and stick this on another label. And this label here, I'm going to span out this way. I'm going to put here output. There we go. So, and then, oh, that's good. We'll just do another one. Alright, so we're going to put the person's name and the age out on our little UI here. Just make it more interesting. Okay, so I was talking about properties and Synthesize. So you can do this with all of the stuff we just did so far. So, because what I really don't want to do is create more setters and getters and all that other stuff, especially for our UI components. It makes more sense to just drag them over, turn them into properties, turn them into Synthesize, stuff like that. And I'm going to use the event here of the ending of the return key. So the did end on exit. So there's a little trick you do for text boxes, and let me show you that, review that concept. I think I showed this to you last time, but we'll look at it again. If you click on the little text box, this is actually kind of optional. You don't need to do this anymore, but if you're working with an older version of Xcode, older API, you are going to have to do this, but it was removed from 7, so you don't have to do it in 7. So, but I'm going to do it anyway. Down here on the bottom, I see the text field. I see the text field properties. So I see here I have the image view properties. Here I have the text view properties. I click on the text view properties. I go down to the center. It says return key. I want it to do done. I want it to send the done notification because I'm going to resign the first responder on that, which means that's the keyboard. Because you know this is going from UI responder. The first responder, when you type into a text field, is the keyboard. So in order to get rid of the keyboard, you resign the first responder.
There are multiple fields?
I'm sorry?
There are multiple fields.
Multiple fields. No, yeah, there are, but that would be a text field instead of an edit text.
After entering the value in the first field, going to the second field, what would be the event?
Say that one more time.
Like if there are 5 fields in the...
Well, we don't have a keyboard usually on a phone, so we usually would type it in there. Press return, you can go to the next one, go to the next one, go to the next one. Is what the default behavior does if you have multiple text fields, like in a form. Otherwise, the user could just press in each one of the text fields if they wanted to.
In VB or something, we define the cursor control.
Yeah, in VB, totally different from Visual Basic, but in VB, it's the same thing. The default cursor control does the order that you put the items onto the screen. This does the same thing, actually. So the default order, if you're using a keyboard with this, but you're not, you're using a touch control. If you were using a keyboard, if the return would go to the next, if there was another one. This one's not going to go anything because there's no next. There's no text, but yeah. Yeah, you got to get out of thinking about a keyboard though, because you don't have a keyboard in here. But anyway, long story short, what was I doing? Okay, so I put this on done, return key. So now what I'm going to do is I'm going to create a method for this event. I'm going to do this event first, actually. So I'm going to click on the little tuxedo icon here that's here. I can actually get rid of, see that where it says blue, it means it's on, which means there's 3 screens. There's 3 parts of this main console here. This is the left part. I like the left part because it gives me my file view. The center is this big screen here, and then the right-hand side is this guy over here. So to conserve real estate, I kind of get rid of I'm kind of a minimalist that way. In fact, if you want to, you can make this column a little bit shorter too. There we go. So you have a lot more room on the screen. And the little tuxedo icon here is going to hold up the middle view because this is the right, center, left. Excuse me, left, center, right. Looking at it backwards. Well, that's anyway. It depends on how you're looking at it from the direction. One side or the other or the middle. Little tuxedo icon brings it up into the middle. In the middle, we got the viewcontroller.m and we got the viewcontroller.h. Why the viewcontroller.m comes up automatically when it used to be the .h, I have no idea. Because I like the .h showing up automatically. But if you don't like which one shows up, you can just do what I did a few minutes ago. So it says automatic. There's 2 of them that are going to come up automatic because they're associated with this view. And how do I know they're associated with this view? That's an interesting question. If I click on the view itself, and if I really want to make sure I'm clicking on the view, I click on the view controller thing at the bottom here. If I go back to the properties of this view, and I look at the class association, I see it says view controller. So this view is linked with this class. So view controller, and if you click on the little arrow here, you can see how you can change it. You can actually create other view controllers, link them with different views, add more views. By default, each view is supposed to have its own view controller. You're not supposed to have all the views on one controller, but you can if you wanted to. It's really not following model view controller correctly. But this is how you link it up. So the class, the custom class. And then what I did here is I clicked on the class icon. Normally you're going to be on this one here. It's going to be the attribute inspector. If you put your mouse over, you can kind of sort of hover and you see the cheat sheet that comes up for you. It says show the attribute inspector, show the identity inspector. Well, I call it a class. It's really the identity. So you can also get it down here from some of the properties, but I like to see it over here. It's a little bit easier. But going back to the concept here, what we have is our view controller where I made my little name. If I wanted to do a property, it's going to have a little @ directive next to it, and it's going to show up underneath. These, by the way, are private. It's private to the implementation. I can only use it inside of the class. Anything outside of this is public. The interface is private to the public, but public or accessible to the implementation. The interface is the underlining public view of the implementation, which is kind of the same way it works in other languages, but we don't normally see it that well. So I'm going to show you, I'm going to drag these guys over here and make properties out of these labels first because it's a little bit easier. Did this last time. You press down on the control button on the keyboard and you drag it over. I believe you don't actually have to press control anymore either. And let's just take a look here. No, you do. Okay, so control, control, and then you let go of the mouse. And you get this little box that comes up, and you can give it a name. I'm going to give it a name. I'm going to just call this one here the name out. So this one's going to be called name out. Let's go name output. And then the type of object that is the data type is a UI label. So if I wanted to, I can create a UI label. And I'll show you that in a few minutes. And the storage is weak because if it's done being used, I want the garbage collector to pick it up. Anything weak is garbage collectible. Anything strong sticks around for the life of the program. It says, don't garbage collect me. I'm strong, I'm going to stick around forever. I'm weak, I'm going to go away. Next time I have an available opportunity. Does it really mean I'm going to go away? Not unless I run out of memory. Half the weak stuff never goes away. Why would it? It's a waste of processing power to go collect something when you don't need it. The memory is not being used for anything. Anyway, so click on create, and you see this little thing over here. It says property. This is what I was talking about before. Property does the same thing as this up here. In fact, I can do this up here. I can go up here and go UI label. That's an image. Let's go UI label. And I can create another label. Another label. And I get another one. If I do it up here, I gotta write setters and getters. And I can write setters and getters in here. Set the name, set to get the name, all that other stuff I just did. This, no setters and getters, I get them automatically. So the interface does it for me. So people like that. So there's two components to it though. This makes it a property. To use it, you gotta synthesize it. So in the old days, it used to synthesize it for you. Now it doesn't do it. You don't actually have to synthesize it if you use an underscore in front of the name. But common practice, make the code readable. Not a bad idea to synthesize it. So if I'm going to synthesize it, I'm going to put it in between the at implementation and the at end. So I got my view controller up here. Excuse me, my view controller.m file, which is which one I'm in. And I'm going to say at synthesize, and I'm going to put this property name in here. What did I call it? Something about the label, the output or something. Let's go see what I called it. I called it, what did I call it? I called it name output. Hi.
I'm so sorry. Can I ask you a quick question? Is
Sure.
there a focus group happening sometime today?
A focus group?
Yeah.
Not that I'm aware of, unless
Okay.
you guys want to
Just wondering.
participate.
Someone's asking me about a focus group. So, okay, thank you.
No,
Sorry.
not as far as I know. You might want to ask Rebecca. Name outputs. Alright, so I guess this is the room they would have used for it. You guys know about a focus group? No? We could do a focus group. Oh, what is this dynamic? I didn't want to put dynamic here. I wanted to put the word synthesize. Synthesize. I don't know how that got changed to dynamic. When I wasn't looking there. At synthesize.
Name output.
What was it called?
Name output.
Name output. Semicolon. Okay, good. Alright, so a little distraction there. So if we put a property over here, what this is actually just the declaration, sort of like this is a declaration. The synthesize actually makes the setters and the getters for us, and it allows us to go set text. And for this is a text UI label. So on a UI label, we have a set text. We have a text property that is done using the set text label. Get text to get the label that's out there. So, which is going to be our setters and getters. This is why I like to use that set and get kind of thing. So I'm also going to put one here for the age. So I'm going to control drag it over here. I'm going to call this one the age. And it's also going to be a UI label, and it's going to be week. So I like to put my properties together so that I can find them. And if you wanted to, you could create another property of your own. You just write at property and you put it in there. And so you can do it manually if you want. Otherwise, there's no need to. So now that now I have that, I'm going to make this one empty. And I'm going to make this one empty because now I don't have to go back to the user interface anymore. I don't really need to do anything with these because these are just labels that are just going to sit there. I'm not going to want to change the labels. You don't have to wire it. And this is called wiring, by the way. You don't have to wire it unless you want to change the label or do something with it. So, the text field is the last item to look at. This one's going to turn into an action instead of a property, which means it's going to be a method. I don't necessarily, I could actually use it if I wanted to as a property. And if I did that, I'd press Control button and come down over here. And I'm going to say name prop property. And if I do that, it's going to be a UI text field. I have it in there. So I could maybe disable, enable, do something to it from a property perspective. Hello. But what I really want to do is use it as an action. And the action I'm going to use is when the user types something in and presses the return key. I'm really waiting for that return key. Because the return key is going to trigger the population of the other two labels for me. Because what I'm going to do on that return key is take the information the user typed in, create a new instance of my person object or my employee, depending upon what I want to do with it, and then use the setters and the getters and populate out the UI with the results. So here I'm going to right mouse click on this round rectangular round style text field, and I'm going to click down here at the top. Excuse me, this did end on exit is the behavior that I'm looking for. We're going to see this. In fact, here actually I can do something with the button. Actually, we'll wire the image view. We'll put a button on here too, just to show you a couple more options in my review here. But this is the text field, so I'm going to call this one here finished text. Finished text. That sounds pretty good to me. I like to change in. We know about ID. It's the generic object. Doesn't have an object type. Could be of any object type. I like to actually tell it what it is. UI text field. I'll show you why in a few seconds here. That's because if I just used ID, it would say ID here. I'd look at this thing going, what is that? If I change the type and actually use it as a UI text field, then when I look at it, oh, that's a text field. And look at that. There's a text field property, and that's a label, and that's a label. Oh, okay. It's easier for me to identify. It's for readability. You don't necessarily need it, though. You can just use it as an ID. We're just going to use basic object behavior with it, so it doesn't really matter. All right, so let's, what did I say? Let's put a button out here, too. Oops. Let's go ahead and drag a button over so we can see how a button works as well, because this is the review. So I'm going to grab a button, stick a button. I'll stick the button up here, actually. And this is going to be a button. Actually, I just leave it as button. There we go. There's my button. Whoops, hard to see the button. Let's just see. Actually, let's do this. I'll grab another image and stick it on the button. So if you don't like text on the button, you can put an image on the button as well. I think I had that website actually up there a few seconds ago. But let me just do something again here. Funny.png. Let's see. Oh, this is pretty cool here. That looks pretty good. There we go. Hello. Let's just put here sun. There we go. The name's too long. You know you don't want to do this in a real app, right? Because this is all copy protected images and you're stealing off of the internet when you're doing this. Not ethical. Just need to say that. Because somebody actually the other day said, well, you take images all the time off of the internet. It's for demonstrative purposes. No animals were harmed in the copying and pasting of those images, and I'm not deploying this into the Apple Store. You try to deploy it and they'll catch you on those images. They'll catch you on borrowed code too. There's a lot of different checks in there. You don't want to be caught by Apple either, because then your chances of ever getting anything in the Apple Store are going to be reduced significantly at that point, because you're going to go through the tight level of check on every single app you try to put in there. Best not to fall into that pattern in the beginning of your career. So, all right. So what do we got here? And they're not as strict as they used to be, but they're pretty bad. So let's see. Did I copy it in here? Done. Oh, well, that's supposed to say sun, but it says D-U-N. Okay, that's okay. All right, you can see how my typing works. So let's go put this label on here. And so I've got my button selected, and I'm going to do a custom button. It doesn't really matter. It just takes away, it makes it look like a button. Let's see, so the image is right here, so let's go ahead and put the dumb on there. Whoa, that's too big. It was a really big image, actually. Hold on one second. Let me just fix the UI a little bit. A little too big for me. Make it a little bit smaller. Oops. Now it's off my page. Oh man, here, hold on a second. Oh my god, it's too big.
We can satisfy that.
Yeah. All right, so let's go back in here and set it this way. Stretch. Someone's got to refresh my memory now. No, that's the content hugging priority.
Yeah, I think that.
I think it's the one underneath the content compression. Is it the content hugging?
The first one actually read height and XY. Read height is at the center actually. And then we can set the height.
Yeah, it's not adjusting for me though. Here, let's just do it this way. Oh, I know. You're gonna complain about this for a second. I'm just gonna pick a smaller one. Let's just pick one of them. I don't like that one. It's too big. This one's cool, actually. This one looks pretty small. This is good. It, you know, for me, it's just I'm just too lazy. It's just. How do you get a PNG out of it? Here we go. A smiley. That PNG. That works for me. I don't like the word done on here anyway, so let's get rid of that done. I'm done with the done. Move it to trash. Here, let's put a smiley in here. There we go. Where'd my button go? Oh, I deleted my button? Put the button back. I'll put the button up here. Moved my little color bright over. There we go. More work than it really should have been. That's okay, wait a minute. This is how I would normally do it, just make it smaller. I know you can change the dimensions programmatically. There we go. I just wanted to show you a button, essentially. Oops, let's just do custom. Trying to get rid of the background, but this one is not a clear background. There's a background on the button, so yeah, we'll just leave it alone. I play all day with the button. Anyway, so we got a button on here, and let's see. Let's wire the button. The reason why I wanted to put a button on here is I wanted to show you the button versus the button press versus the text field. So if I go back to the viewcontroller.h file. And what I'm now going to do is show you what I wanted to show this for you for. So if I right mouse click and bring up the button property screen, I'm going to drag over any one of these events. I can drag over as many as I want. I can have like 20 events all for the same button. It could be a touch up inside, touch on the inside, touch on touch up in value change, this value change, set repeat, double click. If you go into the gestures, then you're looking at touch controls and gestures you're adding to the view itself, not to a button, as an example. So you can put the gesture on the background of the view if you wanted to as well. It doesn't necessarily have to be on an object. But here we're looking at a button. I'm going to just use a touch down event, and I'm going to drag it down here. And this event here is going to be, I'm going to call it button press. Button pressed, and I'm going to change the ID now to a UI button. So what I've done now is wired a button, so I can see both of my two method prototypes here, one for finished text and one for button pressed. And if you take a look at here, if they both said, this is the point I was trying to illustrate actually, if they both said ID on them, how would I know which one was the button and which one was the UI text field? I wouldn't know. So when I'm looking at down here are these two words. This is why I changed them, so that I know which one's the button. Maybe I didn't label it button pressed. Maybe I labeled it, you know, event 1 and event 2. Not going to know which one is what. You know how many times I've looked at code and I've been, it says number 1, number 2, number 3, number 4. And like, what are those things? And then you got to go like this. So if you forget what they are, you can go like this and go, oh, that's the button, and that's the text field. But that's kind of tedious. You should be able to know just by looking at the code. So now if I flip the code over to the viewcontroller.m file, I see now I have the methods already created for me over here. So before when we were creating that person and the employee, I was doing them manually. The beauty of this is that we're using property and synthesize. I actually, when we dragged the actions over, the behavior for us works the same way, except for we don't have a property. We don't have a variable we're setting. Instead, we're setting a method. When we create the method interface, we also get an implementation for that method. So it comes with us automatically. So if we go back to the viewcontroller.m file, we see at the top the @interface and the @end, which was just recently added in the last couple of versions of this Xcode, actually. It never used to show up in the old days. This is for private data. If you wanted to add some private data to the class, you put it here. Not open to the public interface. Can't be used by the public methods outside of this class. So it's kind of in there. A lot of people take it out. I have a tendency to take it out because then I look at that and I can immediately tell what file am I in. If it says @implementation on the top and I forgot to know. Because sometimes I'll be like putting code into the wrong file. And you'll do this all the time actually until you get used to which one you're in. And then when you figure out which one you're in, and be like, wait a minute, why did I do that? There's an at interface inside of the .m file. Anyway, long story short, unless you're going to use it, I usually pull it out. Not a bad idea to use it, however, when you want to just create an instance of an object and just use that object in the implementation, but you don't want that object to be used anywhere else in the project. It's just private to that object. So that's how you're creating private data members and member functions. Put it in the interface that's inside of the viewcontroller.m file instead of its separate file. All right, so back at the wrench over here, we get this little edit text thing, and what we're going to do is we're going to change the labels of those properties, if I can remember what I called them, to the contents, and we did this last time actually, so it's a nice little review. And then we're going to resign the first responder. So just the same way as we ran methods on person and employee, we can run a method here on this particular text field, and we have the text field already. But what we have is the send and receive behavior from the event-driven controller of the app delegate, who is inherited from UI responder. So we have a sender. So I'm going to talk about sender for a second. Sender is how we got there. How do we get there? We don't care how we got there. It's kind of like ID. The equivalence of ID for all of the other objects is like sender for all of the behavior. I can run the method to resign the first responder. I can run it on sender, or I can run it on any of the objects. Well, the only object I really wanted to run it on was this text box, because that's the one that's going to have the responder. What's the first responder from an event-driven perspective? On a UI responder subclass, the first responder on a text field is the keyboard. You type in a text field, the first response you're going to get from the UI is a keyboard's going to show up. It's going to be different and we have different techniques, which is kind of inconsistent. So we have a method to resign the first responder. So it doesn't really matter what the first responder is. It's used more often with the keyboard though. So if I type in here sender resign first responder, we can respond as selector. We can do a bunch of other stuff here, but we resign first responder is going to get rid of the keyboard. Hardly used in anything else, but you could use it for other stuff. If you had a call, if your phone rings, first responder is going to be, do you want to answer it? You're going to get the functionality. You can resign that and have your app pick it up. That's what Google. Actually, that's how Google Voice works. It resigns the first responder on the incoming call, runs a Google instead, or puts up a special screen if you've ever used Google Voice. It says, would you like to use Google Voice, or would you like to use your cell phone service? That's resigning the first responder, replacing it with a substitute kind of option app, and it's an app. It comes up, tells you whether or not you want this one or you want this one. Regardless of which one you pick, that first responder resigns, and then you use the service of whichever one you're using, and then it goes away. Text messaging, same thing. Text message comes in. First responder is going to be your SMS program. So you can create a service to resign that first responder on an SMS and put in something else if you wanted to. So it used to be used, not really used for that anymore. There's other different ways of doing it. So you have the service running simultaneously, which is what you get with a lot of that text stuff. So it comes in here, but it also comes in here as well. So you still get the message. You get the call here, but you also get a call here. So you get logged both ways for everything. But long story short, yeah, you pay for your cell phone. Actually, it used to be you paid for your cell phone minutes, and then you were using poor quality voice over IP Google at the same time. It's like, well, why do that then? You just turn it off. So then people started turning it off. It's like, well, I can't use the name. Well, you can do it on Android though. Android works. iPhone never used to work right. I don't know if it's still working. I haven't tried it in years because I don't use a phone. Long story short, let's go back to this. Excuse me. All right, so the sender, what really was the sender was this text box. This text box is actually up here. I need to know the name of this text box, which is why I'm looking at this here. I made a property for it, did I not? Here it is here. The property is called the name property. All right, so the name property's got some text on it. I'm going to get the text that's on it. So if I get the text on it, I can put the text inside of the label. And the label that I want to put it on is this label here. And I forgot to see what label this one was. This one's going to be the Where is it? Name output. Name output. I say name output. So name property is going into name output. So then now I can write another method here that says name property. Name output. There we go. It's going to be set text with name property. Name property. No, it wasn't called name property. Property something. Oh, let's go see what it is. I want some string here. So let's see. I want to get the string from name property. I didn't synthesize name property. Alright, so now you figured out, or I figured out by trial and error. I typed in and I'm going here and I'm going name property. I don't see name output, but I don't see name property because name property is not available to me in my implementation because I didn't create the setters and the getters for it. I only did it for name output. So if I put a comma in here and put in here name property, which is the one I really want, there it is, name property. Now I have setters and getters for name property. The setters and getters allow me to, through the public interface, this is private data by the way, through the public interface now I can access this component that I've created a property for over in my view controller. So now I have access to it. It seemed like a no-brainer, just automatically give you access, and you can. If you don't want to do this, you use it like this with an underscore. So I could have typed an underscore in, but there's no checking. So the idea is, do you want the checking or do you not want the checking? I like the checking actually. It's error checking. I want to be able to know that what I'm using is visible because there I didn't know it was invisible. But if I use the underscore in front of it, I can put anything I want. And if I put the underscore in here, I can actually go name property. Oops, but it's not going to come up because I made it into a property. But here's name property here. So name property, it's going to be a get text. Or actually, I could just do a text on it because that's the property. So I have the property setting. Let's see what's wrong with this now. Expected. Let's see what this says here. Oh, I hate it when it does that. Expected identifier.
Do we need dot text because we did set text?
Well, I have opening and closing, and I have. I'm just checking my outer my syntax is good. So set the text to. I think the problem is with this here. Let's just do this here. Test. Okay. Oops. Let's just go back this way. Here we go. Actually, we'll just leave it like this for a second. So the problem was with that string that I was creating from the text properties. So I can set the text, get the text. I can get the text from it, or I could use the dot text. The dot text is the text property of the edit text field. It's the text that's inside of it. I could do this. The problem is it wasn't a string. It was a property. So I could do this. I can go like ns string. My string. How about this? Go here. Name is equal to, and then I have to convert the text though, don't I? What was the name of the property? Name property dot text. Actually, this should be a complete conversion though. It is a text. It is, and then I can go here and say name. That works actually. So that's one way of doing it. What I did is that this wasn't returning a string. It's returning a property. If I put this in as a property where a string is supposed to be, it's going to tell me that I haven't converted it. So I can go create a string with property with the text or with an integer or with string, which is a string, and the string I'm getting is out of the string. Create a string. Or create, and if I want to use the property, or I could use the get text. The get text should return a property. So as an example here, actually let's just do this so I don't have to type. Oops, that's not what I wanted. Let's just undo that. Copy. property, oops, name, oops, small name. Text. No, it should be text. There we go. It's text. So instead of using the dot text as the property text, this is the text. So the set and the get, again, now I have to refresh my memory on Objective-C, which is good for me. There's no get. It's set, or what is it? So if you say text, it's set text and text. Set age and age. There's no get age. It just returns the age, which is inconsistent for setters and getter behavior. But anyway, long story short, I could do it this way, and when I have name in here, or I could simply just take this out, which is what I was trying to do before, but I was using the dot in there, which is is returning the property. So the dot is legal syntax in Objective-C, but it doesn't give us the value. It gives us the property. The property is a different format. It could take the property, convert it to a string, then it would be the right format. But why do I want to do that? This is what I'm doing here. Why do I want to do that when I could just use the property? So if I copy it here, stick it in here instead of name, this should work. Let's just see what happens now. And it does work. So I'm going to leave these guys in here again because this is supposed to be a teaching exercise. Because I'll post this code for you guys. So now when I run this here, I should be able to set the label. I think I was going to use an instance of a class, but let's just test this out to see if, make sure we're working correctly in terms of the label. We haven't done anything with the age yet, no big deal. But if I run it now, I should be able to enter a name in, and then the name is going to show up in the name property label. So I'm going to enter in here. You see when I pressed my mouse, or if I had pressed on a screen, it opens up the keyboard. I could type in the keyboard, or I could just type because I'm on the emulator. Put here Barry. If I press return now, I see Barry shows up in the name field. So it's setting and label. So how are you going to get output on your iOS application or your Objectives or your just regular old OS X application? You're going to use a label probably. How are you going to get stuff in? You're going to use a text field, a text box, some form of an entry. What are you going to use for behaviors? Well, you got a button click, or I think that's the only thing I put on here. Or you've got, a line return here. So I can put a lot of berries in there, and I get a lot of berries in there. So the event fires on every time I press the return button on that entry. All right, so the idea, however, was to use this object that we created. So let's go ahead and stop this guy for a second and take a look to see what happens. So if we enter the text in here, we can, let's see, go back to the code, get rid of the bottom. I forgot I still had my NSLog coming out of there. So you notice in the top here, now, if I go back to my view controller, I can see that, viewcontroller.m, I can see that in my viewDidLoad method, I'm creating all these instances. If I know I'm going to use these objects throughout the life of the program, and they're going to be something I'm going to use universally, create a global object out of it by putting it in the viewDidLoad. It becomes available for me. So I have a P1 and I have a E1. And we set P1's name to Bob. So now actually, because I have this instance created, I've initialized it already, I've allocated it, I've assigned a value to it. I'm just going to use P1 now. So actually I can use this here, P1 get name. Here it is, P1.getName. And I can take this and come over here, and instead of taking the property name, it's just, and I'm going to save myself some typing issues by leaving that alone and saying, well, what's wrong? I might need to create it. It's undeclared. I might need to create it as a global variable. How am I going to do that? Well, you look at this and go, well, this is the problem I had with this. I wanted to use P1 down here. I declared it up here. I actually declared it here. So I could take this out and make it a member of this class. If I make it a member of this class, I'm going to stick it in the viewcontroller.h file, and I'm going to stick it right here. Declare it as a member of the class. It's not a member of the class at this point. So I was halfway there on the concept if I declare it in, you're normally going to see 99.9% of the time, you're going to use data in this app, and the view did load. It's going to make those instances of those objects, get all your data model correct, get everything set correctly. Because when you go to this screen, you go to that screen, you go to that screen, you want the same value to be reflected across all these screens. How are you going to do that? You're going to make it member of the class object. If it's a member of the view controller object, if it's a member, it makes it global per se, which is kind of the goal that you're trying to do here. Because you just use one screen. You're going to have the person read a file, read a properties and something, and get the name and the address, the telephone number of the person, and just use it universally throughout the entire app. So the way you do that is you make it a member of the app. So up here, I can say, I have person in here, so I can go person P1. I don't have to allocate it and initialize it initially. I have to put an asterisk in here too. I don't have to allocate it and initialize it initially. Blah. But I could just declare it. And then over here, and then, you know, I could put it up here. I could actually turn it into a property if I wanted to as well. But I'm not going to use the setters and the getters. I wrote my setters and the getters, so I'm just going to put it up here. So if I go over to the .m file, now this should give me an error message, but it doesn't because I've redeclared P1. But I could just do this. I could go P1 is equal to, and then now it's not going to tell me that I've all those. Those are not errors; they were warning messages, but it would have caused me an error. It would have not run for me, which is another kind of a bummer. But now I have P1, so now I actually have P1. I have P1 and in my view did load. I've allocated it, I've initialized it, I've assigned it a value. I've got it ready to go. So down here on the bottom, if I put my semicolon in on the end of this, I should be able to run that method just fine. Actually, because now the value is available. It's visible. I forgot to put that semicolon in there before, but it didn't really matter because this would have had a problem anyway. So let's see. If I want to take now and I want to get the name, well, I think the idea here was let's just copy this here, paste it here. And because that's the manual way. So we want to do P1 get name instead of property text. I want to return the name, but I need to set the name before I can return the name because I want to set it with the contents of that label. So if I do this, then I can go P1, and let's see if I could type this correctly, set name, and I'm going to set it to a string, and the string I'm going to set it to is going to be the property text. So now, I've taken the text that was entered in, created a new, well, at the beginning of this program, I created this new instance of this object person. I've taken the label, excuse me, the edit text that the person typed in, made it the name of this person, P1, by setting the property of the name. Took it, and now I get the property of it. So I have the name, and now I'm going to put it back on the label. It's going to have the same results as we had before, but now it's now using a proper data model. It's actually got an instance of an object here. Let's just call this one Mary. Mary. So we have the same behavior as before. But now if I wanted to use P1, that instance of that object, in another view controller somewhere else, I could just use it anywhere I want. It's saved. So it's the storing of the data that's actually kind of the more critical part of this. Because now I can use it in a game. I can use it over and over again. Because this might change here. And depending upon what else I select, I might have different activity that occurs with what's in here. And so now this is persistent data. This is going to last past this particular screen that I'm on. So anyway, with the age, I can do the same thing. So what I had down here was I set the person's age. And now I have this person here. I could create a constructor. I'm not going to go over that stuff again, but it's an initializer. In the initializer, I can set the data. I can create an initializer just like I created the method. We went over this on the first weekend. And there's a couple of really good examples I gave you on that as well, where you just, it's the same thing as running a method. You just pass the data to the initializer, so you init : You give it a name, you give it an address, or you give it a phone number, you give it an age, whatever happens to be in there. Set the data for you automatically. We're using the setters and the getters to set the age, but let's just go ahead. I'm going to set the age here. Actually, we did set the age. We set the name. You know what? This is a good test here, actually. We want to get the age, right? So we have a get name. Here we have a get age right here. I'm going to change this one to this one here, actually. Let's just do this. So we didn't set the age, but P1 was initialized in the ViewDig controller. We set the name to something. We didn't actually have to set the name, but the name was Bob. Actually, if you look at the output, that's still down here. It's Peter. Now that's E1 is Peter. Bob was the first name, but Mary is the second name because we changed the name because we took it in from the text field. So we set the name again from Bob, the original name, or whatever, yeah, Bob, to Mary. But we still have Bob's age. I think Bob is, what, 21 in here? He's 21. P1 is 21. So we should be able to get 21 showing up then on the screen, which means we're going to either have to convert it or, well, let's see what happens here. Now I have to remember string with int, I think it is actually, but we'll see. So now if I say this other one down here, age, let's take a look and see what this one is called. It was called, I don't have the age property. Here it is, the age property. So the age. So the age. Was it called the age? No, I didn't put the age in here either. The age, there we go. Now it's called the age. Now this is recognizable at least. Let's see, set text. String. Now.
And a string with string format.
Say that one more time.
And a string with string format.
And a string. I have to start typing in order to remember what it's called. Is it in a string or string? Is it in a string? Yeah, in a string.
Space string with string format.
Shoot. No, it's string with string format, but I think I have to define the string, create the string, put the string in here, or, which is probably going to be easier than doing it this way. Here, I'll just do it this way right now. What I want to do is take the age, convert it to a string, so I can do, is it in a string colon, string with string format?
And a string space, string with the string format.
Yeah, see now it's going to do it, but wouldn't do it when I was inside. It would not do it when I was inside of the other method call, but it should do it this way. So the string with format, no, I want to say string with, string with int, not string with format, string with integer. String with content, string with string, no, string with format. If I do string with format, then I can do the format on the string of the, what is it? I have to take the integer though. Let's just do this. Do you remember off the top of your head, or I gotta go look it up?
%d and
yeah, I have to format the string, don't I? Yeah, actually, let's just do it this way. So I'll just create the string then with. No, that's not gonna work. Yeah. Well, let's see. I don't know if this is going to work or not. Let's just take a look here. No. No. Get rid of the brackets here. Expected the bracket. I don't think I can do the string that way. Anyway, long story short, I have to convert this number to a string. But yeah.
If you put the bracket on the beginning. And
Oh, wait a
end,
minute.
Yeah. Sure.
Yeah, but I have to add it to something. Yeah, wait a minute. Then, actually, let's just do it this way, because I don't want to cut and paste all that and stick it next to set text. So I'm going to do it this way. A string. Finished. Going to be equal to, there we go. And then take finished and stick finished in here. There we go. All right, we got it. But now the string is going to say that this string, let me fix the string now. Because I was sloppy. Let's just do this. Now we have the age. All right. So what we did is we created a string with a format. We did a formatted string. There's a string with int, but I can't remember how. It's not string with int, but it's like that. It's similar to that, but I can't remember what it is. Those are one of those things I generally just go and look it up, actually, because I can't remember all the methods in the language. But long story short, in order to create a string, you can create a string with a string with a format, string with an integer, string with a float, string with a double, and you're converting the string data type, the non-string data type to a string. It's a string conversion technique using a method on an object to convert it. Everything's an object in Objective-C. Long story short, we're taking the age, which is going to come back as an integer, we're copying it into a string, and then we're formatting a string with a formatted string. And we're calling the string finished, and we're putting the string in here, we're setting the text to finished. So now if we run it, it should say 21 for the age. Even though we haven't set it, we set it in the view did load. So let me scroll up a little bit here. I'm going to set the name to Mary again, even though the Mary in there is Bob. So if we go down here, so now we have age 21. So we have the expected behavior. It's coming out of the integer that we're getting from P1, which is the person object. And so now if I look at the bottom output here, still have some really nice debugging stuff where I have that initial, I don't know why I left that one there, but the name was Bob, the age is 21, and I had the employee Peter, and then I had P1, the age is 21, but it's just because I ran the method to get the age. I don't know, maybe I printed it out, who knows, but I probably created an NS log for somewhere, but long story short, this is what we wanted to see. We wanted to see the 21 here, so I can still change it to Larry. I'm going to have the name changed to Larry, and I believe, no, we got 21 being printed out again, so I must be printing out that. I must be printing it to the NS log as well. So if I wanted to, I could have the button functionality do something. I'm not going to go that far. I don't think we really need to, but let's just take a look real quick to finish this example out. If I come back to the code, I can see I can do something down here. This is on the button press. On the button press, I could just, let's just do something on the button press. Let's just change, enter. Let's just take and make this hidden. So we can change the hidden property of this because it just round out our property thing. So on the button press, we're going to take that edit text. What was the edit text called? It was called a name property. Name property, and then we can go dot hidden as an example, and this could be equal to true. You're going to wonder, where did I get this hidden from? Well, I got the hidden. Whoops, we got a problem here. Expected identifier.
I usually use yes instead of true.
You use what?
Yes instead of true.
ES?
Yes.
Oh, yes. Actually, the message went away. I think true would work. It could be yes or it could be false. Is it? If it didn't, that's the case. It's a colon yes, I bet. Or is it a colon yes no?
No.
Or is it?
Only yes.
Well, let's see what happens here. Let's just see. And so we're going to have a problem here. So let's just say yes. Is it colon yes?
And I don't use the bracket actually.
Oh, you are correct about that. Let's take the bracket out of there. Because it's not a method that we're running on that. So, there we go. That's our correct syntax. So, hold on one second. Just let me run this real quick. So this one here, and then I can stop and we can take a short break then after we do the attendance. So now we have the button. If we press the button, the edit text went away. So I can't put it back because there's no button to put it back. So let me stop the simulator. I'll run it one more time for those people who weren't paying attention. So we can finish up this example. So I can still use the button. I can still use that. So I've demonstrated the functionality of it. So now I'm going to press the button. You see the button, the property went away. So there used to be I want to say true still works, but on the property itself, if you click on the right hand side, you can see the attribute inspector over here. Where is hidden? If I could find hidden on this little menu here somewhere, there's a hidden property. You can set hidden to true or false. Here's hidden right here. So hidden height, that's the button, excuse me. If I do the text property here, that's where I really want to adjust it. Any one of these components here for the enabled, disabled, selected, highlighted, all those things can be changed to true, false, or yes or no for the Boolean on and off. So, which is a good demonstration of the button functionality. So I think we've done enough for this one, so I'm going to stop this video.